Hey, good morning everyone. Today we will go through a simple tutorial to learn random forests very quickly. Also, as you know, random forest is one of the most important uh, machine learning algorithms. Random forest has many advantages, especially if your data is imbalanced. Random forest is a very good model to use, specifically if you have a lot of overfitting in the data and you want to reduce the variance. uh, Random forest is the go-to model. Specifically, if you want to reduce the variance in your model, random forests is a go-to model. So let's see quickly as to how random forests work. So from your data set, you pick a random sample with replacement and aggregate the predictions. So this is called bootstrapping. The bootstrapping means you take a random sample and replace. So every time you create a sample and replace, and you take a subset of features. So the this m can be based on any formula. So it could be a log of the total number of features or square root. So it depends on what kind of subset you want to make. So the basic idea is to build a series of trees. Excuse me for the spelling. Each of the trees have to be independent and uncorrelated from each other. So the for any new prediction, the prediction will be based on a majority vote or average of predictions across all trees. So there'll be about one third of the observations which in each tree, which are called out of back samples. So the predictions are generally made on the out of back samples. So this kind of determines the accuracy of the trees. So to give you an analogy of how random forest works, right? Say you want to watch a movie and you're not sure. In your mind, you have about 5 movies or 6 movies to watch. So what you do, you call up 6 of your friends, say 3 of your best friends, and say, "Hey, I have these 3 movies. Which is the one which I should watch?" So your friend will, out of the 3 movies, out of the or the whatever 5 movies you have shortlisted, 3 of your friends will recommend that a particular movie should be watched, and some of your friends say some of these movies should not be watched, some can be watched. So you will have kind of a vote kind of a scenario where every friend of yours will vote for the movie that should be watched. So generally, you will pick the movie which has been suggested by your friend, right? In analogy, so basically, whenever a new observation comes in, you will generally predict based on the majority of vote for all the trees. So basically, any new observation that comes in is passed through all these trees, and eventually you assign a prediction based on the majority of vote. There is something called the log of large number. It says that if you repeat an experiment infinitely and large number of times and average the result, so what you it should be close to the log. So basically, if you keep on taking a lot of samples and say you take the mean of the samples, and eventually you will kind of approximate the mean of the population. So this is called the large of law of large numbers. Again, there are two kinds of way you can classify the predictions. One is hard voting, so you just predict the class which gets the most votes, or something called soft voting. You predict the class with the highest probability averaged over all the trees. So generally, because you are doing a majority opinion, there is uh, less variance. But of course, you will have a so if you know the concept of bias variance trade-off, you will generally have lower variance for random forest. Some of the hyperparameters that you can use are number of estimators, maximum features, number of depth, minimum number of samples. So maximum depth is actually will determine your overfitting of the tree. So these are samples just to regulate the the depth and the kind of trees that you want to build. And one more important question that you might face during interviews: what is the difference between boosting and bagging? Boosting works to reduce the bias, bagging works to reduce the variance. So each model is run sequentially. The output of one model influences the other. Here in bagging refers to random forests in general. Each trees can be run independently, can be run parallelly. Boosting, some trees have more weightage than the others. In bagging, all trees have equal weight. So this is a short video on how random forests work. We will implement random forests in the next